Hello everyone. So today we are going to solve another interesting problem number 1730 on lead code. The name is shortest path to get food. It's a premium problem on lead code. So I have found its synonym on lint code, and here the problem number is 3719. Shortest path to get bubble tea. So they are exactly the same problem, just the name are different. So without further ado, let's dive into the problem. So let me explain you the problem and you can read more about the description here. So here what the problem says is we have been given one m cross n grid, and star is our starting position in the grid. So this is our starting position in the grid, uh, which is represented by star. Then x is a obstacle, which is represented by cross x. Empty land is represented by 0. In here in problem it is 0, but it is mentioned in the examples as 0. So that's a error which lint code needs to figure out and make it correct. And this is a hash represents our food. So what they want us to do is they want us to tell the number of minimum steps required to reach from where we are starting position to our food. So in the grid we are located at location over here, and from here if we travel one step here, two step here, and three step we can reach to our food, right? So this is one route. Similarly, if we travel like this, one, two, three, this is second route. Here also the number of steps are three. And if we start from here and go down and take a right and then move another right, so that's another three. So these are the three steps. These are the three paths which we can take to reach our food. And in all the path, the minimum number of steps are three, right? So this is the problem definition and what we can do to solve this problem. So here what we can do is so what we can do is we can apply. So there are two standard algorithms to solve these kind of matrix problem. One is DFS and another is BFS. So I'm going to approach with BFS, and what we'll do is in a typical BFS we'll take a queue for processing, we'll add cells one by one, and then we'll explore the directions, four direction from our starting position in which we can travel, and we can travel only in the path of empty land. And then again we'll look into the four directions from the empty land where we are to reach to our food. So that's the typical BFS. And now I'm going to write the BFS of how I'm going to apply this BFS into our code. So that will be like this. So the very first thing that we need to find is the length of our rows and column, which will get by length of grid, and length of grid will give us the total number of rows, and length of one list inside the list of grid will give us the number of columns. And we need one also queue for processing, so that we will get from DQ, and DQ is written in the collection. So from collection we'll import our DQ, and what more further things we'll require, we'll just collect them as we move along, right? So now we need to the very first thing that we need to do is we need to find the starting point, starting position in our grid. So for that we'll do is we'll traverse in the grid along the rows and then along the columns, and we'll check if we have reached to our uh, reached to the cell where we have the exact starting point, which is represented by star, and if it is, then we want to add that row comma column cell, basically the cell, to our queue for processing. And once we have reached to our starting cell, we need to mark that position. So there are two ways which I'm going to show how we can solve this, apply this BFS. So the first approach what I'm writing is, this is the BFS algorithm that I'm writing out, and in this I'm writing out when the input modification is not allowed, and another will I will show where the input modification is allowed. So currently I'm solving for when the input modification is not allowed, then how we can solve this algorithm, then how we can write this algorithm to solve this problem. So for that we need one visited set. Here we'll using the visited set, what we'll do is we'll mark our cell as visited, that this is the cell which I have visited and I don't want to visit it again, right? So we have found the starting position, and now we'll apply the BFS algorithm. So for that we need directions as well, in to traverse in the four directions. So those would be 1 comma 0 and minus 1 comma 0 to go to down. No, this is left and right, and 0 comma 1 is up and 0 comma minus 1 is the down position, right? And now we'll need one answer variable which will hold our number of steps taken, and we'll start the processing in our queue. And for the very first time we need the cell coordinates, cell position, which we'll get by popping out the elements from the left in our queue, and we need to process this queue until it has been exhausted. And when we are doing that, we need the element when we are processing, okay? And as soon as we enter the queue, we have taken one step in the grid. So we'll update our answer, which is the basically minimum number of steps to get food. And we have popped out the elements, and now we need to explore in four directions. So for that we'll increment the steps by 1. So for that we need to add these direction coordinates into our existing cells to get the new row and new column, so which will be I plus di in moving in the x-axis, and j plus tj if we are moving in the y-axis vertically. And now what we want to check is we are within the boundaries for our cell basically. So if I'm here, so to check if I'm inside the boundary, what I will do is I will put a condition of checking the new row and new column in which I cell I am, that it is within the bounds of my. So this is my total number of m rows, and here it is my total number of n columns, and I need to check that this is within my bounds limit. So that I will add the condition over here. So we'll check that if my new cell row value is less than m, and the new column value is also less than n, then what we need to do is here we need to check if our grid has been if the new cell in which we are checking is it is free. If there is no obstacle, means it's a free land, it's an empty land, so that we can check uh, with the condition for that if it is 0 and the new cell is not visited as well, then we'll mark this. Then we'll add the then we'll first mark this cell that we have visited this cell in when we are visiting the cells in 4 direction from the current cell, and like we don't stuck in the loop, so for that we need to mark this cell again and add this new cell into our queue for processing further, and we'll mark this as add to avoid uh, getting stuck in the loop, right? So this is our condition for exploring the neighbors, 4 neighbors again. So this is for exploring, and now we need to find our minimum number of steps. So for that we need to check that if our grid, when we are exploring the grid in the 4 direction and we have reached to our food that we want to get, that is where we want to get, if we reach to that position, then we want to return our answer, and if we don't find such position, then we'll return just -1. Okay, so let's test out the algorithm that we have written, so and see. Okay, so I have missed the step. I have not called range in which we are traversing. It is length of q. This syntax error happens, smalls. Okay, so this has been accepted, and let's submit our solution and see how it performs for all the test cases. So it has been accepted by all the test cases. So this approach has a time complexity of O of m by n, because we are exploring all the cells and we are also storing all the cells, so that will make us a space complexity of O of m by n. So that is our time and space complexity for the BFS where input modification is not allowed. And like I promised, I need to show you when the input modification is allowed. So what we'll do in that case, we don't need to hold any set. So our space complexity will reduce from m by n to O of 1. And we just need to mark the grid where we are adding it to the set previously. So this time we'll mark just them with the variable that we have been given. So I will mark them as obstacle, so that we don't need to travel back into this Right, so I'll say that this path has been explored, so I will mark it as uh, obstacle so that I don't go into this direction further. Similarly, I will do when I'm into a new cell, so here also I will mark it as X. So that's the only change we need to apply, and let's run. Okay, so it says I have, okay, so we don't need this condition as well. So let's run again. So this has been accepted as well, and let's submit our solution to see how it performs for all the test cases. So this has also been accepted for all the test cases. So this is the typical standard BFS problem of applying the BFS algorithm to the shortest path problems and how we can solve these problems. And before moving, I wanted to also comment on why we can apply BFS and not Dijkstra over here. So the reason simple is, so what the question was, that why BFS and not Dijkstra's, since we are finding the shortest path. So Dijkstra's is the standard algorithm to apply if we are finding shortest path in a grid. So we can apply BFS here because our graph or the grid that we have today, this grid is unweighted, meaning there are no weights associated with the cell, no weights with the cell. And if this condition is true, then we can blindly apply BFS into the problem for solving. And if the graph or grid is weighted, then we need to apply Dijkstra's. So I hope this problem is clear to you, and let me know if you have any particular problem that you want me to solve. I will be happy to have a look. Please like and subscribe to the channel. It helps me to bring more such awesome content for you guys. Thank you and have a nice day.